Lesson 3 was properties and changes of matter. Sorry, that's takes from my mom. So what is matter? A good way to conceptualize it is all objects are things that are tangible, like you're able to touch them in your hands, like this. A more sciencey explanation is anything that has mass and volume. So properties of matter can be chemical or physical. So to be chemical, it means property that becomes evident during a chemical reaction. Whereas physical is a property that can be measured and observed without changing the chemical composition. So without a chemical reaction. So one is shown with a chemical reaction and one is shown always. You don't need one. Okay, so is it chemical or physical? Flammability. 3, 2, 1. It's chemical. It becomes evident during a chemical reaction. You can't really always look at something and know if it's going to be flammable. Next one, reactivity. 3, 2, 1. This is also chemical. You can't, again, look at something without any sort of experiment or chemical reaction and know if it's going to be reactive to something or not. And then in terms of physical properties, this is the kind that you can just observe with your eye. There are two types. There's extensive and intensive. So extensive depends only on the amount of matter. So whether you have a big portion of it or small. And intensive is something that depends on the type or identity of the matter. So is it like metal? Is it a liquid? Is it shiny? Things like that. Okay, so extensive or intensive? Size. 3, 2, 1. This is... Okay, I'm back. So size is, of course, extensive. It depends on the the amount of matter there is, not the type. Mass. 3, 2, 1. This is again extensive. It matters on the amount, not the type. 3, 2, luster. 3, 2, 1. This is intensive. Luster, it's kind of a weird word. This is the first time in chemistry class, it's the first time I'd ever heard of it. It means how shiny something is. So that's something that you can see with your eye. So that's intensive. Length. 3, 2, 1. Extensive, it again matters on the size, obviously. Conductivity, 3, 2, 1. Intensive, metal will be, you can conduct with metal no matter if it's big, small, but you can't conduct with like, I don't know, hay, you know? It matters on like the kind of material it is, not the size. Density, 3, 2, 1. This is intensive, and it's really important to know the equation for density, so it's mass divided by volume. Yeah, it's intensive. So an object will not be, density is not extensive because as something gets bigger, both the mass and the volume will increase with it. So you're not changing your value for G because M and V will be going up in the same ratio to each other. But it varies from material to material. Okay, and then this is a good little way to think about something about classifying properties, if it's chemical or physical, and then if it is physical, if it's extensive or intensive. So take a look at that. I'm sure you really can grasp what makes a property what it is. So, time for a little day in my life. This is just a little quiz on what you know right now about chemical and physical changes, and then there will be some definitions for that at the end. So, just going off of what you know as of right now before reviewing it, what daily chemical and physical changes will I see? Okay, so it's the morning time for breakfast, but oh no, the apple that I was going to eat for breakfast is rotting. Is rotting a chemical change or a physical change? 3, 2, 1. Rotting is chemical. Time to get ready, but my ring is rusting. Is rusting a chemical or a physical change? Rusting is chemical. And I'm at school, and Mixby has asked me to shred some papers, and I accidentally shred all of your tests. Is shredding chemical or physical? Physical. And I'm home now, but oh my god, my sister left the freezer open and melted the ice cream that I was going to eat for dessert. Is melting chemical change or a physical change? 3, 2, 1. It's physical change. Okay, and lastly, I'm ready to go to bed, so I'm going to boil myself some tea. Is boiling a chemical change or a physical change? It's a physical change. Okay, so chemical and physical changes. A chemical change is when a chemical reaction forms new products. So like we saw, rusting, rotting, and then also combustion and digestion. And then a physical change, matter changes form but not chemical identity. So melting, shredding, boiling, chopping. And a good way to think about it is a chemical change is more like irreversible, like you can't go back on it. This is kind of like, I don't love to think about it this way because there's a lot of, it's hard to go back on some physical changes as well, but I don't know, if it helps you, that's another way to think about it. Okay, now your matter lab. This is where you went around and recorded some mass and volume, density, all that. So 2 important terms from this lab that we learned were qualitative and quantitative, and these 2 terms will follow you throughout the rest of your journey in any like STEM class, so it's good to know them. Qualitative is describing the qualities of a substance, and quantitative is measurable observation. So qualitative is like, it's red, it's shiny. Quantitative is like, it's 3 feet long, it weighs 2 pounds. So, some examples. Okay, graphing density. This is also important. So if you think about it, why am I just leave my, okay. The equation for density is density equals mass divided by volume. So when you think about that, it makes sense that the mass goes on the y-axis and the volume goes on the x-axis. And our units for mass are grams, and for volume is milliliters. So this line here represents density, and like the slope of the line is representing the density. So the mass, or the y, over the volume, the x. And it makes sense when you think about the equation for slope. Change in y over change in x, or rise over run. And another important thing from the lab covers making detailed observations. This is really important when it comes to something like claim evidence reasoning, so kind of like writing to explain your thinking. I don't know if this is in the slides, but I do just want to say it's super important to be very thorough in your writing and really like explain all of the terms you use evidence, and then relate it to your claim. Okay, so making detailed observations, you need 1, state of matter, 2, color, and 3, texture and transparency. So some examples are a pink transparent liquid. Another example is a red smooth solid. You have the state of matter, color, and texture transparency. Okay, 1.4. Sorry, this is getting kind of long. There's like 60-something slides in here. Okay. Chemical symbols. So this lesson, the goal is to understand basic chemical formulas and symbols. So there are different elements, not like periodic elements, like features of a chemical symbol and the chemical formulas. So here we have a chemical formula, and let's kind of talk about the different parts. So there are like 3 different parts to think about. So you have the chemical formula here, so magnesium, oxygen, hydrogen, the chemicals. And then you have a subscript, which tells you how much of a certain molecule or chemical there are. So hydroxide, this OH, we can see that there's 2 of them, meaning that there's 2 oxygen and 2 hydrogen. And then for magnesium, there's no subscript, so we just assume that there's 1 magnesium. And then this blue part is the phase of matter. So that's either going to be an S, an L, a G, or AQ, and that we'll go over that soon. But yeah, this is the different features of a chemical formula. Okay, so phases of matter, you do need to include these when you're writing a chemical formula. So you have solid, liquid, gas. I don't really think I need to explain that. And the new one would be aqueous, which means dissolved in water. So a good example of that is salt water. It's an aqueous solution. Salt is dissolved in water. Yeah, and for that, the symbol is just AQ, and you add this to the end of the formula. Okay. And then the law of conservation of mass. Mass cannot be gained or lost during a chemical or physical reaction. Basically, the big idea, matter cannot be created or destroyed. It just kind of changes states, changes how it looks, but it's never created or destroyed.